Hey guys, welcome to day 24 of 100 Days of Code. Today we're going to learn about working with the local file system and also understanding how directories work. And by the end of the day, we will have improved our previous snake game, where previously or currently, the way that it works is it just game's over once we hit a wall or once we hit a tail, which is fun, but it could be better. Imagine if we could also keep track of the high score. So if a user gets a score that's higher than the previous high score, then if they game over, then the high score is going to be updated so that we can keep trying to better ourselves at Snake. And once we've learned all of those skills of manipulating file systems, reading and writing to file, then we're going to create a project that's going to save us a lot of hassle and automate our lives a little bit using Python. So the situation is, let's say you need to write lots of letters. Maybe you're having a birthday party. Maybe you need to write wedding invites, or maybe you just need to email all your clients. Well, let's say that you wanted to personalize a part of that file. Say, for example, the part where you say, "Dear name." Well, if you had a list of names and you wanted to create separate letters using each of those names, so maybe one that says "Dear James," one that says "Dear Emily," and then we just work down the list and keep replacing parts of our letter with the names in our list. So we end up with a whole bunch of letters ready to send out. Depending on what kind of jobs you might have, this is something that could come in really handy as a part of your work or maybe just in your day-to-day lives. And we're going to get started using Python to automate parts of our lives and get Python to do a lot of the repetitive tasks that we don't want to do. And so we can spend more time watching Netflix and playing video games. First, let's start by improving our snake game, getting it to be able to keep track of the high score that we attain each time we play the game, so that we can see what our high score is and keep striving to better ourselves. Open up the snake game in PyCharm that you created a few days back. Now, if you can't find your snake game project, or if you've made some significant changes to it where it might be confusing to follow along with the tutorial, then simply just head over to this URL, which is in the course resources, and then you can go ahead and hit download as zip, unzip the downloaded file, and then open it inside PyCharm, and you should end up with the same project as I have here. And once you've done that, then we can begin to start adding the functionality to keep track of the high score. Firstly, I'm going to add another attribute to my scoreboard, which is going to be called high score. And again, it's going to start out as 0. Now, the next thing I'm going to do is I'm going to replace this game over method with a new method. We're not going to stop the game and write game over anymore. Instead, we're going to reset the scoreboard. So what happens when we reset the scoreboard? Well, we need to figure out if the current score that the user has attained is greater than the high score of all time. And if that is the case, then we're going to update the high score with the value of the current score. So the code for that would look something like this. If self.score is greater than self.highscore, well, in that case, then self.highscore is going to be equal to self.score. Now, this looks a little bit confusing at first, but if you just go through the logic and think about how you would create a high score saving mechanism, then you'll pretty quickly understand what's going on here. Now, once we've updated the high score, the next thing to do is to reset the score. So I'm going to reset it down to 0. Now, remember, the order of your code matters a huge deal, because if you first set the score to 0, then it's never going to be greater than the current high score. So this will never get triggered. So as always, be careful where you're writing your code. Now, after we've set the score, then we need to update the scoreboard. Now, one thing that I've changed about the scoreboard is previously when we increased the score, I've used the self.clear and then self.update scoreboard. But it actually makes more sense for this clear to happen every single time we update the scoreboard. So I've added this method call here before we actually write the score. The reason why I couldn't do this previously is because when we wanted to show game over, we wanted to keep the score on the screen and then for the scoreboard turtle to go to the center and write game over so that both of these things show up on screen. But now that we're getting rid of our game over method, then we can go ahead and move that clear to update scoreboard, and then we don't have to call it twice, both in reset and increase score. Now, in addition to writing the score, I'm now also going to write the high score. And this is going to be using an F string to insert self.highscore. Now, if we run this game as it is, you can see it says score 0, high score 0, using these initial values. But as soon as it hits the wall, it ends because in our main.py, we change this game is on to false, and that ends our while loop. Instead, what I'm going to do is I'm going to delete this game is on equals false and also delete it when we collide with the tail. And I'm also going to delete the part where we call game over from the scoreboard. Instead, I'm going to get the scoreboard to reset itself. So that way the score gets reset to 0 and we're ready with the next round. So now if I run this game again, you can see it says score is 0, and then as soon as we get a higher score and we end up dying, like so, then our high score goes to 2. But our snake kind of just disappears because it continues moving in the same direction. And it's now probably somewhere all the way down to the left. What should we do instead? Well, our snake also needs to be reset. So let's create a reset method inside the snake class as well. And what we're going to do is we're going to get all of the segments to clear. And when I hover over this clear, you can see what it does is it's going to remove all of the items from that list. So all of the segments that we've added already to the list of segments is going to be deleted. And then once we've gotten rid of all the segments, we're going to call self.createSnake again so that we create another 3 segment snake in the starting position. Now, in addition, I'm also going to set the self.head as the 0th element from that list of segments. So basically, we're doing everything that is in the init because we're going to initialize the snake again back at the center. So now if I go back to main.py, and in addition to resetting the scoreboard, I also get my snake to reset. At this point, when I run the code, you'll notice that it's not behaving quite the way you expect it to. So I can go ahead and score, and when I die, I get the high score, but my old snake is still lingering on screen. So even though we've cleared the segments, we don't actually get rid of the turtles that are still on screen. And in order to get rid of them, we actually have to send them to a different location. In our snake reset method, just before we clear our segments, so while we still have access to all of them, we're going to use a for loop to loop through all of the segments in the list of segments and tell each of them to go to a place that is off the screen. So our screen is only 600 by 600, and I'm going to tell it to go to 1000 x 1000y. So it's going to disappear off the screen. So this way, notice how when the snake hits one of the walls, or when it hits its tail, instead of sort of just staying there, it actually disappears into a location that's off the screen. So that way we can keep track of our high scores, we can continue to get higher scores, and if we get a score that's not quite as high as the high score, and we end up dying, then the high score stays as the previous value. Now, the only thing about this game is that in order to end it, we have to hit the stop button here. But once we've done that, it also reveals the crucial flaw in our code. Because if I run our program again, you can see that, wait, what happened to the high score, right? We had a high score of 3 previously. So, what exactly is happening? Well, the reason is actually quite simple. We know that if we create a variable, let's say we create a variable called a, set it to equal 3, and then at some point we set a to be from the input. So now when I run this code, you can see that initially a is equal to 3, but then the next line, I ask the user, what do you want a to equal? So I'm going to make it equal to 12. Now at this point, if I go ahead and access this variable a inside the console, just by typing a and then hitting enter, you can see it's equal to 12. Now, similarly, I can add some print statements here. I can print the value of a and then also print the value of a after we modify it. So again, you can see initially it's equal to 3, but then I decide to change it to 12. So now it's equal to 12. Now, what happens if I rerun the code? A is equal to 3. Again, it's reset itself because the code is being rerun and the previous state is not being remembered. In our case, we've got this high score variable, which initially starts out as 0. And at some point during the game, as we progress, we modify this high score variable to equal a new value, let's say 3. So now if I go ahead and print my high score, you can see that it's equal to 3. But as soon as I rerun the code and this goes through, then all of that progress gets reset. And now if I print the value of high score, you can see it's again equal to 0. So this is what's happening in our program as well. So how might you keep track of the score if you weren't using Python? Well, you might open up a Word document and then write down your high score in that document, close it down, and then the next time you play the game, open up that file again and see what your previous high score is. We're going to try and do the same thing, but using Python to read and write to a file so that we can save our progress and be able to retrieve our previous high scores each time we play the snake game. To find out how to do that and to solve this problem, head over to the next lesson and we'll talk about how to use Python to open, read, write, and close files on your system. In this lesson, I want to talk about the file system and how you could use Python to open up files, read files, write to the files, and also close them down again, all without touching the mouse. So that way we can start saving our high scores into a file and retrieve it the next time we open up our program. Let's start out by trying to do some of the simplest things with a file, reading and writing. Now, I've created a new project using PyCharm called Day24, and I've created my main.py where we're going to write our Python code. But in addition, I'm also going to create a new file, which is going to be called my_file.txt. So this is going to be a text file. Now, inside this text file, I'm going to write some text. Hello, my name is Angela. And if you want, you can actually find this text file inside your project folder, and you can actually open it up with your native text editing software. So TextEdit on Mac or Notepad on Windows. And you can see it's just a bunch of text. There's nothing really special here. But what we can do using Python is we can actually open up that file. So notice how this method open is an inbuilt method. So you don't have to import anything. You can use it directly. And it takes a number of inputs. The file that you want to open, the mode that you want to open that file in, and a whole bunch of other optional things that you can specify. In our case, I'm going to specify the name of my file as a string. So my_file.txt. So remember that extension. And then I'm going to open this file and I'm going to save it inside a variable called file. So when we hit run right now, nothing's really going to happen. You're not going to see anything happening, but behind the scenes, Python has already opened up this file and it's ready for the next operation that you might want to do on that file. So the next thing I want to do is I want to read the file. And this read method returns the contents of that file as a string. So we can now save it inside a variable called contents, and I can go ahead and print out this contents. So when I hit run right now, you can see what gets printed out is the content from my file.txt. And if I go ahead and modify my file to add some more lines and I hit run again, you can see that all of the lines are being printed. Once we've opened the file, we've read the file, and we print the contents that we have read. At the end of all of our work, what we have to do, once we're done with that file that we've opened, we also have to close it. If there's an open, there's probably going to be a close. Now, why do we need to close the file? Well, once Python opens up that file, it basically takes up some of the resources of your computer. And at some point later on, it might decide to close it and free up those resources, but we don't know when that's going to happen and if it will happen. So instead, we're going to tell it to close down the file manually using this line of code. It's a similar concept to having lots and lots of tabs open in your browser. While it's kind of convenient to have all of these tabs open, if you actually want your computer to perform at its best, you actually want to only use as many tabs as you need. Every extra tab is going to add a little bit of burden to your computer. And especially if you're using a very heavy application like Chrome, which likes to take up a lot of resources of your CPU and your computer, if you have more than 20 or 30 tabs, you'll notice a significant decrease in the speed of your computer. So here's a computer tip as well as programming tip. Always close down tabs that you've opened and always close down files that you've opened. Now, because it's kind of hard to remember to close a file, because we might be doing lots of other things in between the open and close, right? We might be writing to the file, we might be modifying it or reading it line by line or doing lots of different things. So instead, what many Python developers opt for is a different way of opening the file. We can use a with keyword. And with, we can open this file and then we can open it as whatever it is we decide to name. So this you can name to anything. You can name it as f, you can name it as file. It's basically equivalent to that variable that we created earlier on, which stored the opened file. Now we can indent the rest of this and I can delete this file.close. And you can see that it works exactly the same as before, but now we no longer have to remember to close our file just by adding some keywords here. This with keyword is going to manage that file directly. So as soon as it notices that we're done with it, it'll close down the file. It kind of makes me wish that something similar for tabs existed. But let's get back to our Python code. So now that we've opened up my file.txt, we've saved it into a variable called file, we've read that file and saved the contents that we read into a variable called contents, and then we've printed it. Now, what if instead of reading the file, I wanted to write to it? Well, it's just as simple. So we can get hold of our file and then call write. And we can put any sort of string inside this write method to put into our file. So let's put some text, let's call it new text, and I want this new text to be written into my file.txt. And if we run the code as it is, you'll notice that it doesn't work because it says that unsupported operation, this file is not writable. And this is because we opened up the file in read-only mode. So remember when we took a look at some of the parameters for this method open, one of them was called mode. And by default, it's set to read-only, so R. Now, if we want to write to it, so make it editable, we have to change the mode to W for write. So now if I run the code again, you can see that process finished with exit code 0, which we know to mean that everything was successful. And if I take a look inside my file.txt, all of the previous text got magically deleted and replaced with the new text that I wanted to write. Now, if you don't want to delete everything that is in the file, but you just want to add to it, then you can change this mode from W to A. And A stands for append. So just as we like to use list.append and then we can add something to the end of the list, well, the same thing happens with appending and writing. So I can write my new text and I can add a new line. Remember, we can use \n to add a new line and then add the new text. And now take a look at the after version when I hit run and we write this new line and new text by appending it to my file. It's gone at the very end of the file here. Now, one of the important things you need to know when you're writing files is when you try to open a file in write mode and that file doesn't exist, then it's going to actually create it for you from scratch. So let's go ahead and create a file, which I'll call new file.txt. Make sure you've got the extension in there. And we have the mode as write set. Because this new file.txt doesn't exist in this folder, then it's actually going to create it for us. So now when I hit run, you can see that once this goes through, that new file gets created and the new text has been written inside. Now remember, this only works when you're in the write mode and when that file doesn't currently exist. So those are some basic ways of working with the file system. We can open and read, we can open and write. And by using these different modes, append, read, or write, we can define what it is that we want to do with that file that we've opened. Now that we've learned how to work with the file system, in the next lesson, I want to show you how we can fix our snake game so that we can write to a text file our high score. And every time we open up and run our game, we fetch that file and see what the previous high score was so that we can load it into our game. So for all of that and more, I'll see you in the next lesson. It's time for your challenge. You've already seen how we've managed to get the snake game to keep track of the high score. And when the user scores a number that's greater than the high score, then we replace that high score with the new value. But unfortunately, as you saw previously, at the moment when we run this game and we achieve a new high score, the next time that we run the game again, that is completely lost. So the first thing I want you to do is to right-click on your project, create a new file, and call it data.txt. So we're going to create a data text file. Now this data text file is just going to contain a single number, 0. And we're going to use the data that's in this data.txt file to keep track of the high score. And it's your job to figure out how you can convert this simple attribute here, high score, to, instead of using a number that we've just created in the code, I want you to use the number that's inside data.txt. So you'll need to read from it here, and then later on you'll need to write to it when we reset the game and check if there is a new high score. Everything going well, you should be able to run the game, achieve a new high score, and then stop and rerun the game and still see that high score showing up. Think about what you learned in the last lesson. Have a think about how you can convert the text in here into a number using what you've learned in previous lessons, and pause the video and give this challenge a go. All right, so we know that we've already got this file data.txt and it already contains the number 0. So instead of using this line of code, we're going to be reading from that file to get that 0. Let's delete this line of code And instead, I'm going to open my file with the file name that is data.txt. And the file name is, of course, a string, like you see here, wrapped in quotation marks. And we're going to use the with keyword so that we don't have to bother about closing the file again. We can get Python to manage it for us. With opening this file, and I'm going to save that file to a variable called data. Now I'm going to use that data and read from it. Now, once I've read from it, I should end up with some sort of string that's going to represent the contents of this file. So that string will need to be converted to an integer if we want to use it as a number which we can increase and change in our game. So I'm going to type convert it into an integer. And then finally, I'm going to save that as the value for our new attribute self.highscore. That's the reading part done, and if we run our code as it is, it should already work as it did before, but it won't have the feature that we want, which is to be able to quit out of the game, stop, and rerun. So it's still not saving the latest high score to that data.txt. You can see it's still 0. So where do we want to save it? Well, it's got to happen every time we adjust the high score. When the score is greater than the current high score, we set the high score to the new score, but in addition, we're going to read from our file data.txt. So let's use our syntax with and then open again, and let's pass in the name of our file data.txt. And remember that we also need to change the mode to W for write, because otherwise it's not going to let us write to that file. Now, once we've opened it and we've saved it as a variable called data, then we can write to that data using data.write. And what are we going to write to it? Well, we have to write a string. So let's use an F string to convert our current self.highscore into a string and then write that into our file data.txt. Now, notice what happens when I run my code. So I'm going to achieve a new high score of 2, which is I'm very proud of. And now if I hit stop, take a look at data.txt. It's been updated, it's been rewritten by these 2 lines of code. So now if I rerun my program, you can see it already is showing my previous high score of 2, and I can keep playing this game and accumulate my high score, and all of that data will be saved to my file data.txt like that. So did you manage to get this right? And by the way, if you see this keyboard interrupt, don't worry, that's just because we clicked on the stop button to stop our program, because it wants to keep on going forever until we achieve the highest score of them all. The point of this exercise is to try and get you to review what we learned in the last lesson, which is opening a file, reading the file, and also writing to the file, and remembering the mode that we have to change. And hopefully you'll start to see how this could be really useful in terms of improving the usability of our programs and our games. Now, in the next lesson, we're going to talk more than just about files. We're going to talk about file paths and directories. So for all of that and more, I'll see you there. All right, so we've seen how we can open and close files as well as read them and write to them. But files don't just have a name. They also have a path or a way of getting to them. For example, here in this map, if we wanted this dinosaur to get to the golden egg, there's many paths that it could take. But if we wanted to give it some directions as to how it might arrive on this path, well, we might say, continue forwards at the volcano, turn right. And then when you see a snake, turn right again. And when you see the coconut tree, turn left, and you will get to the cave with the egg. Now, on computers, it works quite similarly, but we have to remember that on the computer, there's files and there's folders. So files can live within folders, and you can navigate through several folders deep in order to get to a particular file. So let's think about what the file paths might be for a computer that has a structure that looks like this. So the first thing to note is that at the very root of all of the files and the folders is basically the origin, right? This is the root folder. And on a Mac, you can see that our PyCharm projects live within my users folder, inside a folder called users, inside a folder called Macintosh HD. So if I have this folder selected right here, I can say go to enclosing folder, which is this one. And then if I keep doing this, you can see it keeps jumping up until it can go no further. So the root on a Mac is the Macintosh HD, the hard drive. And that, in terms of a path, is represented by a single /. Now, when you're on a Windows computer, however, the root folder is usually your C drive. So that becomes your root folder. Inside our root folder, our Macintosh HD or our C drive, we have a folder called work. Inside that folder, I've got a report Word document as well as a project folder. And then inside that project folder, there's a PowerPoint called talk. Now, if we think about the file paths for each of these things, this is what they might look like. The root is obviously just a /. The work folder will be /work. Report will be /work/report.doc. Project will be /work/project. And finally, the talk will be /work/project/talk.powerpoint. So this path is kind of like the direction that we were talking about previously. It's a way for the computer to navigate to the file of interest, which in this case might be the talk.ppt. And we have to give it directions for which folder to go into and then which folder, and then you'll find the file with this name. Now, this is known as an absolute file path. Absolute file paths always start off relative to the root. So you'll always see a / to begin with, and sometimes you'll see C:, or on a Mac, you'll just see the /. This absolute file path is basically a path that starts from the origin, the root of the computer storage system. Now, there's also something called a relative file path. Taking this talk.ppt, we know that the absolute file path is /work/project /talk.ppt. But what if we were actually inside this project folder? So let's say that at the time when we're trying to get to this talk.ppt, we're actually right here. Now, this in computer speak is called the working directory. It's basically the directory or folder that we're currently working from. And once we've established a working directory, say that we are right here, then we can use what's called a relative file path to get to a file that we're interested in. So given that we're here and we're trying to get here, the relative file path is simply just /talk.ppt. The / signifies look in the current folder for this file. If we switch up our working directory, and let's say we are now working from the work folder, how do we get to this talk.ppt? Well, the absolute file path would not change for this file, but the relative file path would now be /project/talk.ppt. So we're walking from here to here to here. Now, what if we wanted to go upwards in the directory tree? Let's say we wanted to get a hold of this report.doc, but we are currently working inside this project folder. How do we go one step up? Well, we would write ... so 2 dots now, /report.doc. So we're inside this project folder, we're coming out of it to the parent folder, which is the work folder, and then we're getting hold of this file. So that 2 dots represents going one step up in the hierarchy to the parent folder, which in this case is the work folder. Now, What we've been doing is we've been writing code inside our main.py. And that main.py has usually been inside some sort of project folder. When we're trying to get hold of a file, this is basically where we are at. So our working directory is the work folder. So that means if we wanted to get access to this report.doc file from our main.py, all we need to do is write /report.doc because we're working within the same directory and we're just getting hold of this file. Now, when you're using relative file path, you can use this /, but you can also shorten it and get rid of it as well. This is why we've been able to open this myfile.txt, which is in the same folder as my main.py. And notice how these two files are at the same hierarchical level. So let's do a quick challenge. I'm going to delete the part where we write to the file, and I'm going to change my file so it just has one sentence. And I'm going to locate this file by using Reveal in Finder. And on Windows, that would be right-click and Show in Explorer. And it would show you the location of that file in your computer system. Now, what we're going to do is we're going to move this file to the desktop. And what I want you to do is I want you to go to the desktop, right-click on that file, and if you're on a Mac, I want you to click on Get Info. And if you're on a Windows, I want you to right-click and go to Properties. Now, what you're looking for is this location here. Now, you can see that this current file, new file, is located under the root folder, which in this case is the C drive, /users/lunanappary/desktop/newfile.txt. On a Mac, you can see that it's located under the root folder, which is Macintosh HD /users/angela/desktop/myfile.txt. Here comes your challenge. Now that we've moved our file away from our project, I want you to fix this code so that when you run it, it won't give you this file not found error, because at the moment there is no myfile.txt in the same working directory as our main.py. It doesn't exist inside this folder. Have a think about what you've learned so far and see if you can change this path so that our code works again. And it's the same on Windows. Use the location of the file on your computer and use the absolute path in the code to get it to work. Pause the video now. Alright, here's how you would use the absolute path. So we know that our myfile.txt is located in the root folder, and then it's users Angela desktop. So let's go ahead and change this string. Let's start at the root, and then let's add the next folder, which is users. And then let's add another slash, and then we go to the next folder, which is Angela. Now, of course, this will be different for you, but finally we go to our desktop, and then we can get to our myfile.txt. So this is the full path to get to this file. So now if I run this code again, you can see it's able to read the file, there's no errors, and it's getting hold of the contents of the file. Now on Windows, it's a similar story. So we know that the location of the file is root, then users, then lunanappary, then desktop. Again, this of course will be different for you depending on your username, but you should see it in your location when you take a look at the file properties. So let's change this. Let's start out at the root, which is the C drive, and then let's go to users. And then we go to our username, which is London Appary. And then we go to our desktop. And that is where it should find this new file.txt. So now when I hit run, you can see that it's able to fetch that file and print the contents without any errors. Now, one of the peculiarities about file paths in Windows and Mac is that in a Mac, the path, each of the folders are separated by a /, whereas on Windows, they're separated by a \. But as you've noticed, when we're writing Python code, we don't care about that. We can just write it as / and making sure that we have the root, which represents the C drive, so this entire part, and then we have our folder, the next folder, the next folder, the next folder, etc. So now comes the next challenge. You can see that this path follows from the root folder, which is the C drive, and on the Mac, it's also from the Macintosh HD. So what if we wanted to change this so that it's relative to our current main.py? Our main.py, if we go to Show in Explorer, you can see that the path for this file is the following. It's under Users, under Linapri, /PyCharm project /Windows demo. So that's the name of my project. And then afterwards, it's my main.py. So this is a bit of a tricky question. Given that this file is inside this current folder, or whatever it is that you have as your folder which contains this file, how can you get it to use a relative file path so that it jumps back 2 folders to the London AppRe folder and then goes to desktop and then to new file? On our Mac, it's a similar story. So we go to Reveal in Finder, we can see this is where we are currently. So our current working directory is this day 24 project folder. So if we go one level up, and the shortcut is Command up, we go to our day 24 folder. So this is our working directory. Now, if we want to go up one level, we can go to Go, and then go to Enclosing folder. So one level up, that gets us to PyCharm projects. And then if we go one level up further, we get to our Angela folder, at which point we can then navigate downwards to desktop, myfile.txt. This is your challenge. Figure out what the relative path to the text file on your desktop should be, then modify the code and get it to work. Pause the video now. So the way that we would modify this is, in order to get to this Angela folder where we can continue to our desktop and then to my file, we have to go up 2 levels. So that translates to .. And now we're inside the Angela folder, so we can start going down. And PyCharm is smart enough to know what your folder structure looks like. So it'll start giving you hints as to what folders are accessible at this level. So I can get to desktop and then I can get to myfile.txt. And if I go ahead and run my code, you can see it's able to read and print the content of that file. The main difference between an absolute file path and a relative file path is the absolute file path is always relative to the root of your computer. On Windows, that's the C drive. Usually anyways, unless you've changed it. And on a Mac, it is the Macintosh HD. Now, the relative file path is relative to your current working directory. So it depends on where you are and where you're trying to get to. Now, depending on the situation and where that file you're interested in is located, you might decide to use the absolute file path or the relative file path. And you can see that in this case, it's not necessarily that much shorter or that much more easier to understand. So if you know how to do both, then you can adapt to the situation and figure out which one is most appropriate. Now, I know that paths can be confusing, so that's why I've come up with a whole bunch of quiz exercises for you in the next lesson for you to get more practice with file paths so that you can feel confident leaving this lesson. So for all of that and more, I'll see you on the next lesson. Alright guys, it's time to put what you've learned to the test. Now in this project, we're going to be doing a little bit of mail merging. So mail merging is where you take something like what we have, a list of names, for example, and we want to insert each of these names into a letter. So instead of saying, "Dear name, you are invited to my birthday this Saturday," it should say "dear," and then it would replace that with whatever is here. Take a look at this example file. You can see that it replaced the name placeholder with the first name in the invitednames.txt file. Your objective is to write some Python code to automate the process. So what you're going to end up with is a bunch of letters, one for each of the names inside the invitednames.txt, and the letters are going to be named like this: letter underscore for underscore, and then the name of the person. And they're going to be saved in a TXT format, which you can open either in Google Docs or in Microsoft Word. And it's basically ready for printing. So I've made it a little bit harder for you by adding in a whole bunch of folders. And each of these files are nested inside a bunch of folders. So for example, starting letter is inside letters, which is inside inputs. And then the letters that you're going to generate are going to need to go into this folder called ready to send, which is inside output. And no cheating. I don't want you moving around any of these files. You're going to be using what you've learned about directories and file paths to do everything without needing to drag and drop or move anything around manually. I've got some starting files for you. So the first thing I want you to do is to go to the course resources and download the zip file, which will be your starting project code. Once you open it within PyCharm, it's going to ask you to configure the interpreter. So you can either go ahead and click on that pop-up, or if it disappears, then just click on the event log and then click on configure a Python interpreter and then select the latest interpreter that you have installed. So in my case, it's 3.8, but by the time you're watching this, it'll probably be 3.9 or even later. And once that's done, then you can go ahead and have a look inside main.py. So here I've got some instructions for you. First, you're going to create a letter using the starting letter.docx, which is right here nested 2 folders deep. And then you're going to use each of the names inside invitednames.txt to replace the part where it says name with the actual names that you see in names.txt. And then you're going to save each of those letters that you've generated inside the folder ready to send. And you can take a look at the example if you want to see what the final outcome looks like. So it's going to be the name without any spaces afterwards, just a comma. Now, there's going to be a few things that will trip you up along the way. And I'm hoping that you're going to use your knowledge about how to get help from Google and Stack Overflow, as well as some of these hints that I've left in here for you. So the hints take you to 3 pages of Python documentation, and they're chosen because the methods that are featured in them will definitely help you in this project. In fact, some of the things that you're going to try to do won't be possible unless you take a look at each of these pages of documentation, read through it, and understand what the methods do. Now, as always, with a lot of tutorials, it's impossible to teach you every single method, and it would be really, really tedious if I just went through all of the methods that are available in Python and showed them to you individually. So instead, you have to work just as a pro developer does, which is to find out information when you need it and to quickly understand what's happening and how to use the information you found on the fly. Don't worry if you haven't seen me use these methods before. You will get more practice by using the documentation, figuring things out yourself, and implementing things that you haven't seen before. Once you're ready, go ahead and take a look at each of these links, see what each of the methods I've linked to does, and then go ahead and try to tackle this challenge. So pause the video and I'll see you on the other side. I hope you've given that a good go, and now I'm going to run through the solution with you. Here I've got those 3 links open, and they're all documentation on W3 schools for different methods in Python. The first one is a method called readLines. It's really important that you have that S because there's also another method called readLine, the singular form. What readLines does is it returns all the lines in the file as a list where each line is an item in the list object. For example, we can run this example and you can see that inside this demo file read lines, there's several lines in that file, and each line after running this method gets added as an item inside a list, like this. Now, the next method I showed you is the Python string replace method. And what this method does is it will replace a specified phrase with another specified phrase. If the starting text was I like bananas and you do text.replace, you can replace the part where it says bananas with apples. And when you print, you can see the end outcome changes that text to I like apples. Now, the final method that I showed you is the string strip method. And what this does is it will remove the spaces at the beginning and at the end of the string. So if our starting text has a lot of white space at the beginning and the end, and then we do text.strip, it'll get rid of all of that extra space and it ends up with just the word. Now, if you have a space in between another word, like this, if we hit run, then you can see that it keeps the space in between the words, but it gets rid of any spaces on either side, which is really, really handy. And you're going to see, hopefully, why it's really, really useful. So now that we've reviewed these 3 methods that we haven't seen before, and normally you would probably find these when you actually get stuck and when you're searching Stack Overflow. But now that you're aware of those methods, let's go ahead and create a letter using our starting letter. So I'm going to go ahead and delete everything in here. And now let's go ahead and tackle this challenge. So the first thing I want to do is to get hold of all of the invited names, and I want to turn them into a list. Now I can, of course, rather tediously go and add some square brackets, add some quotation marks around it, and then add it into my main.py, but I don't want to do that. Instead, I'm going to get Python to read the file. So using our classic syntax with open, I'm going to open up that file. But in order to open it up, I need to specify a string, which is going to be the path that leads me from here to here. So let's think about how we might get there. Now, this input-output folder is on the same hierarchical level as our current file where we're writing our code. If we want to use a relative file path, we can simply say, go into the current folder, which is mail merge project start, and then find a folder called input. Inside this folder called input, we're going to go to another folder called names. And then inside that folder of names, we're going to get hold of that file called invitednames.txt. And PyCharm is super clever and it helps you out with a lot of typing, so it saves you some time as well. And then I'm going to save it as names file. Now that I've got this file open, I'm going to go ahead and read it. So namesfile.read. And once I've read it, I'm going to save it to a variable called names, and then I'm going to print out my names. So now if I go ahead and hit run my main.py, you can see that it prints out all of these names individually because it's getting hold of everything that's in here and just printing it out. Now at this point, I would really like these names to be in the format of a list. So if you remember, that's where this read lines method is going to be really helpful because it returns a list containing each line inside the file as a list item. Now, instead of saying namesfile.read, let's replace that with read lines. Now, when I hit run, you can see it prints out names, and names is now magically turned into a list. So now that we have our list of names, which we've extracted from our invitednames.txt, then we can go ahead and proceed to the next step where we're going to replace this placeholder in our starting letter with each of these names. Let's go ahead and create a constant at the top, which I'll call placeholder, and I'm going to set it as the string, which is the square brackets and then the word name, because this is the string that we want to replace from our starting letter. The next step is to open up our starting letter. So again, I'm going to use open, and then I'm going to specify the path. So from here, I'm going to go into the folder that's at the same level as this file. So using the /, and then I'm going to go into input again, and then I'm going to go into, instead of names, I'm going to go to letters. And I'm going to get hold of my starting letter, and I'm going to open this as the letter file. With the letter file, I'm simply just going to get hold of the letter contents by saying letterfile.read. And this is going to be a normal read because I want all of the content inside that letter, and it's now going to be saved as a string inside my letter contents. The next step is to go through the letter contents and replace that placeholder with the actual name that we've got in our list. To do that, we'll need the second method that I showed you, which is the replace method. So we can get hold of the text, call replace, and then the output of this method will be a new string which has modified this text. In our case, we'll need a loop. So we can say for name in our list of names. Let's go through each of the names in that list. And then let's get the letter contents and replace the placeholder, so the old string, with a new string, which is going to be the name. And once we've replaced it, then we're going to save it into a new letter. Now that we have our new letter, let's go ahead and print it out and see what it looks like. So you can see all the contents of each of the letters being printed. But other than the very last letter that looks pretty normal, every other letter has a new line after the name. So remember when we printed out each of these names, you can see that after each of the names that they've extracted from this list of invited names, there's a new line that's being added. And you can see that with this \n. The only one that doesn't have a new line is the very last one. What we need to do is to strip the new line. Does that remind you of something? Well, we have a method that we saw called strip, which can take away any of the spaces at the beginning and at the end of the string. And then we can end up with an output, which is the string without any of those leading and trailing spaces. We're going to loop through each of the names, and then we're going to take the name and we're going to call strip on each of those names. And then we can save it to a variable called stripped name. And now we can use that stripped name instead of the name. Now, if I go ahead and print out our new letter, you can see that each of the letters look exactly like how we want them to be. All we need to do now is to write them into a new file. In previous lessons, I mentioned that when you open a file that doesn't exist, Python will actually create that file for you. Again, using our with open, I'm going to navigate to this ready to send folder. Going from where we are in main.py, we're going to go to the output folder, and then we're going to go to the ready to send folder. And then inside the ready to send folder is where we're going to create our new file. So let's think about what we want our file name to look like. In the intro, I showed you this is the format for each of the files. letter_for_ang.txt. And then this part is replaced by each of the names. So let's write that letter_for_ the name and then .txt. We can use an F string to replace this part with the stripped name. So now we should be creating a new letter for each of the names in our list of names. So now let's refer to this file as the completed letter. What we want to do with this completed letter, which at the moment is blank, is we want to write to it. So to do that, we have to change the open mode from default, which is R for read, to W for write. And this will allow us to get our completed letter and write to it. What do we want to write in there? Well, we want to write the new letter that we've created, of course. That's pretty much the end of our code. And all we have to do is to go ahead and hit run. And once I hit run, you can see there's a whole bunch of letters that have been generated over here. And if I click on each of them, you can see that the name placeholder has now been replaced. And I'm now ready to go to the printers and print all of these out. So did you manage to figure out how to complete this project? If not, be sure to review the relevant parts of the lessons today so that you're really confident with what's going on and you understand all of this code. If you want to take a look at the completed solution, then head over to the course resources and you'll find a link to the final project code, which actually works even within Replit. So you can delete all of these files and you can see it generate them from scratch.
Well done for completing today's course and challenges. Now, one of the questions I often see students ask in the Q&A is, okay, so I've written this code, this is my solution, but what's the right solution? And this is something that I want to talk about today. And the really important thing for you to understand is that there is no right solution. It is your solution. It's about your thinking process and how you got there. And when you're looking at the solution, when you're looking at your code, the most important thing is not how fast does it run or how few lines of code you use, how efficient is the code. To quote the godfather of computer programming, Donald Knuth, the guy who wrote The Art of Computer Science and many other books are super influential, super hard to understand. But what he says is premature optimization is not a great thing. Don't try to make your code the most efficient as possible. Instead, what you should aim for is readability. So if another programmer comes along, if another student takes a look at your code, can they understand what you did immediately without a lot of effort? Well, if that's true, then you've succeeded. That is the goal, that is the bar that you should measure your code by. Now, when I was in university and I had to write a lot of essays, especially during the year when I was doing neuroscience as a degree. And when I first started writing essays, I thought, you know what? Good essays are ones with big words. They're the ones with the ones in the dictionary that nobody ever uses. And they had to be really complex. It made me sound super smart. But then I had a professor who was somebody who really was very influential in my life. And he took one look at my essay and says, this is not how you write. You write so that other people understand what you're trying to say. And it's actually the same thing with code. It's not about writing big words. It's not about shortening your code to the shortest number of lines. It's about making your code expressive, readable, and as easily understood by as many people as possible. Once you've gotten there, eventually, once you become a senior developer, you'll have your own ideas about style and syntax, but at this stage, optimize for readability.